Okay, here we go, section 1.2. Like I said, a little easier because you don't have to do any three-dimensional drawings today. And again, a lot of this is just laying the foundations for things we're going to do throughout the year. The first one is called a postulate or an axiom. It's a really fancy term in mathematics, but when we get into we start proving things, you guys become the lawyers in math, you're going to have to prove certain things. And when you prove it, just like a lawyer proves something in court, you have to be able to justify what you're doing. You have to have a reason. So a postulate is something that we're going to call on later to help prove things. In a postulate, it's a rule accepted without proof. It's basically a commonly accepted belief. I like to think of it like religion. Okay? People have different religions, they believe in different things, but it's hard to prove religion. Okay? I mean, it might be hard to prove somebody's religious belief. Whereas if you have a theorem, like the Pythagorean theorem you dealt with last year, that's actually a rule that can be proved. I like to think of that like science. Okay? In science we can prove things. So a postulate's like religion. We just have to believe it. It's something everybody kind of accepts. In a theorem we can actually prove it. And we'll be using those throughout the year. We'll have a couple of our first postulates today. They're not too bad. Just fancy words. Coordinate, we're going to define that in a little bit. They have a picture, and I think it's easier to define it with the picture. Same thing with distance. We'll get that in a second. So we'll go to between. Between's our next vocab word here. I mean, between. How do you define between? Roberts, you're between Dana and T, right? Okay. But is Nicole between TK and Alexa? Well, isn't his row here and her row here, and isn't she between them? So it's a little wishy-washy, right? So in geometry we clean it up by saying for things to be between each other, they have to be collinear. They have to lie in a straight line. So from a geometric standpoint, we'd say Nicole is not between them because those three people are not collinear. They're not in the same line. So here's a picture. B is between A and C. They're all collinear. And B is between them. Then we've got congruent segments. You guys have dealt with congruence and similarity a little bit in your previous math classes, but congruent just means the same. So if two segments are congruent, they have the same length. Now notice we've got a lot of different ways of writing things. I could call this line, what could I call that line? What's a name for that line?
Line AC.
Line AC? Use A and B for me.
Oh, A and B.
Okay, we could call that line AB. And how would you write it, Farley?
The line over it.
Yeah. That would be line AB. And yesterday we talked about to write a segment, you just don't put the little arrows on. So this is talking segment. But what about if we just don't have any designation above it at all? And that, when we designate it that way, we're just talking about their length. So this says the length of AB is equal to the length of CD. All right. If we say they're congruent, we use this fancy symbol here. You guys have probably seen it before. We say they're equal, okay, because they're the same length, but they're not the exact same line, so we designate that with the little squiggly on top of it. Just means they're congruent. They have the same length, but they're different lines, okay? Finally, how do you designate on a picture that two things have the same length? Anybody know what that? There's a way to designate on a geometric figure if two lines have the same length. Donnelly, you know it? Yeah, it's that little red hash mark right there. That just means that the two lines have the same length. And if you had a figure, I don't know, let's see. Don't make fun of my drawing skills now. I'm not even going to put my drawing skills to the test. I don't trust them this early in the morning. Okay? Boom. Copy paste. Whoop. Okay, we're not going to use this one. You guys agree that these two figures are congruent? Same size, same shape. So I could indicate that side lengths are equal by going like that. So can I do this? What's wrong with that picture, Harmony?
You have to put 2 lines.
Yeah, if I put a hash mark, that means it's the same as this hash mark, but we obviously know that they're not the same. So she's right. You'd put 2 hash marks. Okay? And if I had another third side that was congruent to another picture and it was a different length, I'd use 3 hash marks. Okay? You guys got the idea. All right, let's quick define coordinate and distance. Ruler postulate. Here's our first postulate. Now, your note-taking guide is a great resource. You're going to have all these postulates and theorems all right there. And sometimes people have a separate notebook with all their postulates and theorems. I don't think we need to do that with our note-taking guides. The points on a line can be matched 1 to 1 with real numbers. The real number that corresponds to a point is the coordinate of the point. It's just basically saying we can assign points, numbers, and what that does is it helps us measure. Okay, we get to measure a little bit. When's the last time you got to use a ruler and measure in math class? That's one of my favorite things to do with a ruler. You guys haven't gotten to do it in a few years. You measure in elementary school. Thank goodness. Do they still teach cursive in elementary? Do they? I don't know if they do anymore. Really? Okay, last part of this postulate. The distance between 2 points. You talked about distance a lot last year when you were in chapter 6. Talking about absolute value, distance from 0, that kind of thing. The distance between 2 points. Again, we said we just write the end points, AB. We don't put any segment mark. We don't put any line mark above them. The distance between 2 points is the absolute value of the difference. Okay. So if I were to make this point 8 and this point 5, what's the distance between them? What do you think? Roman, I see a mouth in it.
3.
Yeah, absolute value, 8 minus 5. Why do you think we use absolute value? Why do they have to confuse it that way? What if somebody else came along and said 5 minus 8 instead of 8 minus 5? What do they get? Sorensen?
You can't have a negative distance.
Good. You can't have a negative distance. So by throwing the absolute value in, they get the same thing. All right. Okay, let's get into some math action. Do you have if you don't have a ruler, I might. I don't know if I do or not. We'll find out. Hey, I got some new rulers. Cool. If you don't have a ruler, why don't you come grab one quick? Okay. Okay, you guys have your rulers. Now obviously it's kind of hard to do with it projected here. It's not the same distance as yours. Go ahead and measure CD to the nearest tenth of a centimeter. Okay, nearest tenth of a centimeter, and see what you get. Somebody let me know when they think they've got it. Parker, what'd you get?
3.5 centimeters.
3.5 centimeters? Anybody else get close to 3.5 centimeters? Yeah? Now, in your note-taking guide, they put a little ruler down there for you, right? And it kind of aligns with, well, they put C with 1, and where does it look like D aligns with? 4.56, 4.7? So if we were to use your note-taking guide, how would they come up with the distance between those 2 points? What operation would we have to do? Dana? Yeah, 4.7 minus 1, so about 3.7, which is pretty darn close to what you guys got with your rulers. Now the other thing, this ruler postulate basically just says you could do this too. Can I do this? I can do this. I could take this ruler and instead of lining it up at 1, what if I were to take it and line it up at 2 instead? What if I put C at 2? Does it change the distance? No, because now it's just 5.7 minus 2, which is still going to give me 3.7. It doesn't matter what you start with. Okay? All right. Take a quick second. Go to checkpoint problem number 1. Measure that to the nearest 1/8 of an inch. Okay, might be off a little bit, but if I was doing this, I'd take my ruler, I'd maybe line it up with 0. Now, according to my ruler, it's about 4 3/4 inches, but that's blown way up on the big screen. Tell me, somebody, what you got. TK, what'd you get?
1 6/8 inches.
1 6/8 inches. How could we reduce that? 1 3/4 inches. Anybody else get close to 1 3/4? Yeah, I mean, I'd say if you're in the ballpark, 1 3/4, 1 5/8, 1 7/8. You know, depending, maybe your ruler, you know, maybe it was a little off. Who knows? All right, let's keep cruising here. Morning, Alex. Postulate 2. Segment addition postulate. Okay, it just says if B is between, and again, if it's between, what does that mean about the 3 points?
They're in a line.
They're in a line, they're collinear. So as long as I know I've got 3 points that are collinear, basically we're just saying, hey, if we take this distance from A to B, and we add the distance from B to C, that's going to give us the entire distance. Okay, not too bad, huh? Not too bad. It's kind of like a number line. Here's 1, here's 4, here's 10. You know, how far is it from 1 to 10? 9. You guys are scaring me a little bit. Okay, how about from 1 to 4? 4 to 10? And 3 and 6 makes 9. Okay, not too bad. All right, so let's take a look at example 2 now, and we'll use the second postulate. Locations shown line a straight line. Find the distance from the starting point to the destination. We know from starting to rest area is 64 miles, and rest area to destination is 87 miles. So how could we find the distance from the starting point to the destination point? How could we find the length of SD? Add together 64 and 87. Break this segment down into SR plus RD. So yeah, 64 plus 87. What are we going to get there? 144, 151? Anybody else get 151? Is that right? 151 miles. Not too bad. Okay. Good deal. So have you guys practice one? Oh, one more here, I'm sorry. Use diagram to find KL. So jump to example 3. What do you think? We know the total distance is 38. J to K is 15. This is algebra right here. Okay, we'll show you how is this algebra. We know that the whole distance, JL, is equal to what segment plus what segment? KL plus JK? Just kidding. Okay. Well, what's JL? What's the length of JL? 38. We know JK is 15, and we're trying to find KL. How is this algebra? What does this look like to you guys? Weber? It's a fence post problem. How are we going to get KL by itself? Yeah, just subtract 15 from both sides. Hey, 25. Now, obviously, I'm breaking it down real thoroughly here. You guys could... Just making sure you're watching. Huh? God darn it. There's my mulligan for the day. I'm going to have to be on my A game the rest of the day. All right, let's have you guys try checkpoint problem number 2. All right, somebody else, help me out. How'd you find QS? Tell me what you did. Dana, what'd you do for QS? Added 30 and 31. Good habit to get into, and I saw a lot of people doing it. They put actually QS, so the distance QS equals 31, instead of just writing 31 on their paper, okay, and not knowing which one it applied to. How about PQ? Somebody tell me how that found PQ. Willard, what'd you do?
55 minus 31.
55 minus 31. So what'd you get for PQ?
24. Yes.
What was it?
24.
24, very good. All right, next idea here. Last example. Yes?
Put Q
QS is 31, size 61.
Is that strike 2? QS. God, you guys are catching me today. 2 mulligans, 1 per 9 hole, right? And I'm on the front 9 right now. Well, no, I guess I just made the turn. So I just had my mulligan for the back 9. Okay? Example 4, compare the segments for congruence. We're comparing the segments to see if they're congruent, which means they'd have to have the same length. So if we plot these different points, let's quick plot the points, 4, 5. Remember, it's like an elevator. You have to go into the elevator. So walk in, walk across, and then you can go up and down. So 4, 5. We're over 4, up 5. Negative 1, 5. So that was F. This is G. H is 3, 3. J is 3, negative 2. And it says determine if FG and HJ are congruent. Well, let me make those lines quick. I guess I shouldn't say line, they say segment because they don't have the little arrows on it. So I'll get my segment tool out. Is this congruent to that? What do you think? It's nice that they're vertical and horizontal lines because I can just basically count dots to find out what their lengths are. If they were diagonal, I'd probably have to use the Pythagorean theorem somehow, but that'll come more down the road. What's the length of GF or FG? You got 4, 4, 5, and negative 1, 5. What coordinate's the same? 5. The y coordinate's the same. So really, the y coordinate has no bearing on what this distance is. How would I find the distance? Which coordinates would I have to work with? X. Remember, we can assign numbers. It's like this is negative 1. It's like this is 4. Oh, distance, absolute value. So we've got 4 minus negative 1. Minus negative, what do you got to do?
Change it to
God, you're so serious, Willard. Minus negative, what do you got to do?
add the opposite.
Minus negative. He's got the benefit of being in my class last year. Chop, chop, right? Minus negative, we've got to sit there and chop, chop, add the positive. So we've got, that distance is 5. How about HJ? What would I have to subtract to get the distance on that? You've got 3, 3, and you've got 3, negative 2. What do you think, Weber?
3 minus negative 2.
Yeah, the x coordinates, they're the same. They don't play into this. 3 minus negative 2, chop, chop, bam. Okay, so they both have the same length. How do I write congruent? Finish it off here. How do I write congruent? Equal sign with squiggly on top. Okay, we're not going to bother with this. You guys got the plan of attack. All right, I think we're good to go.